As we delve into the topic of when AGI will be achieved, we must first grapple with a fundamental question. What exactly is AGI, and how does it differ from the AI systems we have today?
That's an excellent starting point. Artificial General Intelligence, or AGI, represents a level of machine intelligence that can match or surpass human cognitive abilities across a wide range of tasks. Unlike narrow AI, which excels at specific predefined tasks, AGI would possess the flexibility to adapt, learn, and apply knowledge across diverse domains, much like the human mind.
This distinction is crucial. Can you elaborate on some key characteristics that would set AGI apart from our current AI systems?
Certainly, AGI would likely exhibit several key traits: autonomous learning without extensive pre-training, abstract reasoning, transfer learning between unrelated domains, and perhaps most importantly, a form of self-awareness or metacognition. It would need to understand its own thought processes, set its own goals, and navigate novel situations without explicit programming.
Those are indeed formidable capabilities. It brings to mind the various criteria proposed for identifying AGI. How do you view traditional benchmarks like the Turing test in the context of modern AGI research?
While the Turing test was groundbreaking for its time, many researchers now consider it insufficient for truly gauging AGI. Modern interpretations often include multimodal tests that assess not just language use, but also visual understanding, logical reasoning, and even creative problem solving. Some propose that true AGI should be able to learn and master any cognitive task that a human can, given similar resources and time.
This broader perspective on AGI capabilities raises profound questions about consciousness and self-awareness. How central are these concepts to the definition of AGI, in your view?
That's a complex and contentious issue in the field. Some argue that consciousness and self-awareness are essential components of AGI, as they underpin many aspects of human-level intelligence. Others contend that AGI could exist without these qualities, focusing instead on functional capabilities. This debate touches on deep philosophical questions about the nature of intelligence and consciousness itself.
Indeed, the philosophical implications are vast. As we consider the potential societal impacts of AGI, how might its achievement reshape our understanding of intelligence, creativity, and even what it means to be human?
The advent of AGI would likely prompt a fundamental reevaluation of many aspects of society. It could challenge our notions of work, education, and human value. On one hand, AGI could lead to unprecedented scientific and creative breakthroughs, solving complex global challenges. On the other, it might raise existential questions about human purpose and identity in a world where machines can match or exceed our cognitive abilities.
These profound implications underscore the importance of clearly defining and recognizing AGI. Yet, as we've discussed, pinpointing exactly what constitutes AGI remains a significant challenge. This brings us to a critical question. Given the elusive nature of AGI, how can we accurately assess progress towards its achievement?
That's a pivotal question that leads us into the realm of technological development and benchmarking. To truly gauge our progress towards AGI, we need to examine the current state of AI technology, its limitations, and the breakthroughs that might bridge the gap between narrow AI and general intelligence.
As we delve into the technological landscape of AI, it's clear that while we've made remarkable strides in narrow AI, the path to AGI is fraught with challenges. Let's start by examining the current capabilities and limitations of AI in key areas like natural language processing, computer vision, and reasoning. What's your assessment of where we stand?
You're right to point out those specific domains. In natural language processing, we've seen impressive advances with models like GPT-3 and its successors, which can generate human-like text and engage in sophisticated dialogue. However, these systems often lack true understanding and can produce inconsistent or nonsensical outputs when pushed beyond their training boundaries. In computer vision, AI can now recognize and categorize images with superhuman accuracy in many cases, but struggles with abstract visual reasoning tasks that humans find intuitive. As for reasoning, while AI excels at certain types of logical inference, it often fails at common sense reasoning or dealing with ambiguous real-world scenarios.
Those limitations are indeed significant. It seems that bridging the gap between these narrow AI capabilities and AGI will require revolutionary breakthroughs. What potential technological advancements do you see as most promising in this pursuit?
Several emerging technologies hold promise. Quantum computing, for instance, could potentially solve certain types of problems exponentially faster than classical computers, which might be crucial for handling the complexity of AGI. Neuromorphic hardware, designed to mimic the structure and function of biological neural networks, could lead to more efficient and brain-like AI systems. In terms of software, we're seeing exciting developments in areas like few-shot learning, causal reasoning, and self-supervised learning, which are bringing us closer to systems that can learn and adapt more like humans do.
Those are fascinating possibilities. But I wonder, given the vast amounts of data and computational power already being used in AI development, how much further can we push these resources? Is there a point of diminishing returns, or do you see continued scaling as a viable path to AGI?
That's a contentious issue in the field. Some researchers argue that continued scaling of existing architectures, combined with more data and compute power, could eventually lead to AGI-like capabilities, the scaling hypothesis. Others contend that we need fundamental algorithmic breakthroughs. My view is that while scaling has taken us far, it's unlikely to be sufficient on its own. We'll likely need novel architectures that can more efficiently utilize data and compute, perhaps inspired by how the human brain operates with relatively low power consumption.
Speaking of the human brain, how crucial do you think insights from neuroscience and cognitive science will be in the development of AGI? Are we at a point where a deeper understanding of human intelligence is necessary to replicate it artificially?
Absolutely. I believe interdisciplinary approaches will be key. Neuroscience is providing valuable insights into how the brain processes information, learns, and adapts. For instance, our understanding of the brain's hierarchical structure and its ability to form abstract representations is influencing new AI architectures. Cognitive science theories about human reasoning, memory, and decision-making are also informing AI design. However, it's worth noting that AGI doesn't necessarily need to replicate human cognition exactly. It might achieve general intelligence through different mechanisms.
That's a crucial point about the potential divergence between human and artificial general intelligence. It leads me to wonder about one of the most formidable challenges in AGI development: replicating or emulating human-like general intelligence. What do you see as the most significant barriers in this endeavor?
The challenges are indeed formidable. One of the biggest hurdles is developing systems that can truly understand context and transfer knowledge between domains as effortlessly as humans do. Another major challenge is creating AI with common sense reasoning, the ability to navigate the world using implicit knowledge that humans take for granted. We also struggle with imbuing AI with creativity, emotional intelligence, and ethical reasoning. Perhaps most fundamentally, we still don't fully understand how to create artificial consciousness or self-awareness, if indeed these are necessary components of AGI.
Those are profound challenges that cut to the heart of what intelligence and consciousness really are. As we grapple with these fundamental questions and technological hurdles, it naturally leads us to wonder about the timeline for AGI development. How do we go about predicting when these breakthroughs might occur, given the uncertainties involved?
Predicting the timeline for AGI is indeed a complex and contentious issue. It involves not just technological considerations, but also social, economic, and ethical factors. To approach this question, we need to examine a range of expert opinions, consider potential accelerating and hindering factors, and explore different scenarios for how AGI might emerge.
As we approach the final segment of our discussion on when AGI will be achieved, let's delve into the realm of predictions and their implications. The timeline for AGI development is a subject of intense debate among experts. What's your perspective on the current range of predictions?
The range of predictions is indeed wide and varied. On the optimistic end, some experts believe we could achieve AGI within the next decade or two. Others are more conservative, suggesting it might take 50 to 100 years or even longer. It's crucial to note that these predictions are often influenced by differing definitions of AGI and varying assessments of technological progress. Personally, I believe we're likely looking at a timeframe of 30 to 50 years, but I acknowledge the high degree of uncertainty in any such prediction.
That's a substantial range of predictions. What factors do you see as potentially accelerating or hindering AGI development?
Several factors could influence the timeline. Accelerating factors include increased funding for AI research, breakthroughs in quantum computing or neuromorphic hardware, and advancements in our understanding of human cognition. On the other hand, regulatory hurdles, ethical concerns, and the inherent complexity of replicating general intelligence could slow progress. Additionally, unforeseen technical challenges or limitations in our current approaches to AI might necessitate entirely new paradigms, potentially extending the timeline significantly.
Those are important considerations. Now let's explore the potential scenarios for AGI emergence. Do you envision a gradual development or a sudden breakthrough?
This is a critical question. While Hollywood often depicts AGI as emerging suddenly, many researchers anticipate a more gradual development. We might see a series of incremental advancements that eventually culminate in AGI. However, it's also possible that a key insight or breakthrough could lead to a rapid acceleration in capabilities. The reality might be a combination of both, steady progress punctuated by occasional leaps forward. This uncertainty underscores the importance of careful monitoring and governance of AI development.
Indeed, the path to AGI remains uncertain. This brings us to a crucial point, the potential implications of AGI achievement. What economic, social, and ethical consequences should we be preparing for?
The implications of AGI are profound and far-reaching. Economically, we could see unprecedented productivity gains, but also massive disruptions to the job market. Socially, AGI could transform education, healthcare, and scientific research, potentially solving long-standing global challenges. However, it also raises concerns about privacy, autonomy, and the potential concentration of power. Ethically, we face questions about the rights and moral status of AGI, the alignment of AGI goals with human values, and the existential risks posed by superintelligent AI. These considerations highlight the critical importance of developing AGI responsibly and with robust safeguards in place.
Those potential impacts are indeed profound. Given these possibilities, what strategies should individuals, organizations, and societies be considering to prepare for a world with AGI?
Preparation is key. For individuals, this means embracing lifelong learning and developing skills that complement rather than compete with AI. Organizations should invest in AI literacy, ethical frameworks, and adaptable infrastructures. At a societal level, we need to foster interdisciplinary collaboration, develop flexible regulatory frameworks, and engage in public discourse about the future we want to create with AGI. It's also crucial to invest in AI safety research and to establish global cooperation mechanisms to ensure AGI benefits humanity as a whole.
Thank you for those insights. As we conclude our discussion on when AGI will be achieved, it's clear that we're grappling with a topic of immense complexity and significance. We've explored the elusive nature of AGI, the technological hurdles we face in its development, and the wide-ranging predictions and implications of its achievement. While the exact timeline remains uncertain, what's evident is the transformative potential of AGI and the critical importance of responsible development and preparation.
Absolutely. Our journey through this topic underscores that the question of when AGI will be achieved is inextricably linked to how we define it, the technological breakthroughs we make, and the ethical frameworks we establish. As we look to the future, it's clear that the path to AGI is not just a technological challenge, but a societal one. It demands our collective wisdom, foresight, and commitment to ensuring that as we advance towards this remarkable milestone, we do so in a way that benefits all of humanity. The future of AGI is not predetermined. It's a future we must actively shape with careful consideration and collaborative effort.
Thank you for listening. This episode was generated on PodwaveAI.com. If you'd like to create your own personalized podcast, we invite you to visit our platform and explore the possibilities. Until next time,